In this video, we're going to use the fundamental theorem of calculus and the chain rule to find a derivative of an integral function. It says, given capital F of x below, find f prime of x. And they give us the integral from 0 to root x of t squared divided by t plus 3 dt. So you notice they're giving us something different than what we're used to. They're giving us root of x. And we're used to the fundamental theorem of calculus saying that f of x is equal to the integral from a to x of f of t dt. So when we have this, that f prime of x is equal to f of x. Well, now we have something other than x here. So when we actually take the derivative, we're going to end up with a chain rule here. So an example of this would be, now we have f of x is equal to u of x. So the integral of u of x, a to u of x. So this will end up being, so it's ft dt. But when we have f prime of x, what we'll end up with here is we'll get f prime of u of x times, because we're doing the derivative in here, we have to do chain rule, so it'd be times du over dx. So we're going to use this piece to evaluate this now, because I'm going to say u of x is equal to root x. So then I can say now this is really f of x equals integral 0 to u of x t squared over t plus 3 dt. So now I'm going to use this version of it. So I'm going to say that f prime of x is equal to u of x squared over u of x plus 3. And then this dt would be du over dx. So then I have f prime of x is equal to, if I substitute root x in, I end up with root x squared over root x plus 3. And then I would have the derivative of root x here. So I end up with f prime of x, when I take the square of root x, I end up with x over root x plus 3 times derivative of this would be 1/2. Well, we're going to write that here. Derivative of this would be x to the 1/2 is 1/2 x to the negative 1/2, which is 1 over 2 root x. So I'm really multiplying by 1 over 2 root x here. So this is f prime of x is equal to, when I multiply this in, I end up with x over 2 root x times root x. That's going to be 2x plus 6 root x.